All right, ladies and gentlemen, here we go with the Quiz 2 preview for unit number 4. A couple things to go over here with I'm going to shrink this a little bit before we get going. In getting ready over the stuff we've done over the past week and a half or so. So first part, sketch the graph of each function, then tell me the domain, the range, the end behavior, the lead coefficient, and the degree. Good gravy, man. Okay, we got a lot to do with here. So go to y equals here first. I'm going to try to avoid the glare as best I can, but sometimes it's not possible. There we go. Go into y equals. If, let me get this typed in first before I start going into what ifs here. First, make sure you're using the negative down there by enter and not the minus key for the x squared, or you'll have a problem. When you go to graph, typically it's going to be the normal 10 by 10 like this. Okay, we'll get a graph. If somehow somebody has been not nice and has messed with your window, okay, simple way always to get back to this normal window is to just hit zoom up here at the top and number 6 for zoom standard. It'll always put it back to a 10 by 10 for you, just in case. So I've got this, and I'm like, okay, now you're saying just sketch. Do I really just need to sketch? Can I? Yeah, I mean, kind of look. 1, 2, 3, 4, 5. That goes up about 6 and over. So, I mean, I just kind of like to give myself a little dot here, and I'm like, all right. Again, we're not looking for perfection. I mean, that's pretty bad, to be perfectly honest, but we're okay. All right. So we need domain. We need range. We need end behavior. And the lead coefficient and the degree. Holy moly. Okay, let's deal with these two first. My expression, my polynomial, is already in standard form. What does that mean? It means the biggest exponent is at the beginning and it's working its way down. So lucky for me, that's going to tell me my degree because there's my biggest exponent. That's all I need to look for. My lead coefficient is the coefficient on that particular term. So since that's on a 2, this negative or -1 is my lead coefficient. If that would have been my biggest term, 2 would have been my lead coefficient. So we got that. Domain and range. Okay, start with the easy one. Domain, infinite. Every time. No brainer. Don't have to think about it. Range, we got to think a little. Because I see it goes down forever, so I get the negative infinity part with my y's here. But it doesn't go up forever. It goes up to like here is as high as it goes somewhere. And I need to know what that exact value is, especially when I just sketched it. I want to know what that is. So how do I do this? This is where we refer again to what was talked about when we did this initially. We're going to do second trace, and we're looking for the top, so we're looking for the maximum, number 4. So we go ahead, we get that, and there's my favorite guy, the cursor, favorite gal, could be either. We only use the left and right arrows, ever. Never use up and down. So we're going to get as close to that top, that maximum as we think we can. You know, it doesn't have to be an exact science. And then we're going to pay attention to the question here. Left bound means we use the left arrow, and we're going to go left, 1, 2, 3, and hit enter. There's our first boundary. We're setting a trap for the maximum here. Right bound, right arrow. 1, 2, 3. Now don't hit enter yet because we're just back where we started. We go 1, 2, 3 more and hit enter for 6 total. And now I see these boundaries saying, hey, look at here. The max is in here somewhere. Look here. And so when it just says guess and it doesn't say left or right anymore, we just hit enter, and the maximum is whatever the y value is. In this case, the max is at 6. So this was actually the 0.16, but that's the point I care about. Sometimes it'll be a decimal. Don't worry if it is, okay? But if it is, we just roll with it. Now for end behavior, and again, everybody teaches this different, so if I'm a little different on this one for you, I apologize. The x part is always the easy part because one's going to negative infinity and one's going to positive infinity. Your job is to figure out the f of x part. And again, f of x is just a really fancy math way of saying y equals. So, positive to negative infinity. Your question is going to be, what's going on as x goes from left to right? Negative infinity goes to the left, positive goes to the right. So how do I do this part? I'm going to look at the arrows. On the left, I circle the arrow. And I go, okay, is that arrow on my y-axis going towards positive infinity or negative infinity? We're like, well, duh, it's going down towards negative infinity. Y goes down as x goes left. Yes, it does. Then I look at the other one. Hey, what's going on when we're on the right? I find my arrow on the right. Circle it. What's happened to that as far as y goes? Well, Hardy, it's still going down. You're right. Y goes down as x goes right. It does. I'm done. I'm done. So I think what we'll do is we're going to make 2 videos out of this. We're going to do one just for graphing, and we're going to do one just for some of our other stuff. So, okay, number 2, I will get this in here momentarily. I'm going to jot some of this stuff down. Make sure I don't forget any of it. And as I'm doing this, again, just a reminder out there how important it is to practice the stuff where you're not just kind of doing it and going, oh yeah, well, you know, I'll just copy some stuff down. Hopefully this isn't your first look at practicing this whole time, or this could get a little interesting for you. Okay, enough of the Hardy mini lecture. Get this over here. So, all right, we got x to the 4th. So x, it's been a little while, caret button here. That's how we get to the exponents. One other reminder, you see how the cursor is up in the exponent still? We don't like that here. Right arrow to get it down, and minus 2x squared, not negative. I know, picky calculator, it happens. So let's see what we got this time. All right. So it's kind of one of these. That's a much better sketch than that first one. Now I'm getting somewhere. So we'll bring this back in a minute. So I look and I go, okay, where's my biggest exponent? There it is. That's my degree. What number's in front of it? That's my lead coefficient, 1. All right, there it is. Domain and range. Well, we said on the first one, domain I never have to think. It's always infinite. It's always forever left and right. Range, however, I see up forever, but where's the bottom? Looks like these 2 points are in about the same place. So again, I need to make sure, I need to check, I need to do second trace, but this time I'm doing minimum because it's at the bottom of my graph. So, do my min. It doesn't matter which one I do not need to do them both because they look like they're about the same spot here. So, that looks pretty low. Left bound, left arrow. 1, 2, 3. Enter. Right bound, right arrow. 1, 2, 3, 4, 5, 6. Enter. Bounds are set. Here we go. Now, glad this came up because we've had a discussion about this in my class before. You're looking at the y value, and I'll have a lot of people write down 2.59. That's not what it is. You're like, well, what is it then? Whenever you see E show up, okay, that's scientific notation, meaning, hey, move the decimal point 11 places to the left. Now, if I did that, that's kind of ridiculous here. So let's see. So 2, 5, 9. Did I get enough? No. 10. Okay, so that'd be 0.0000000000259. What's that real close to? Anytime you see E, it's just 0. Okay, we're not taking that many decimal places here. We don't have time for that. So anytime you see E, we're just going to go with 0. Okay. And then for our end behavior again, reminders, I like to label my axes. I like to label all of them to make sure I don't do something silly. Left arrow. Which infinity is it pointing at? Positive. Right arrow. Which infinity is it positive? Freudian slip, pointing towards positive. And I'm done. Okay? Kind of starting to catch on here a little bit. Kind of catching on. Okay, one more to play with. And the nice thing with this is you can rewind me, you can mute me. I don't know how much good that would do you, but I suppose you could try it. I'd feel bad about it, but, you know, it is what it is. All right, one more time. X cubed, right arrow, plus 9x squared plus 24x plus 20. All right, what do we get this time? Ooh, little dipsy-do here. All right, so about -5, -2, and up we go. Okay? Again, just a decent sketch. Got to do all the things. Let's kind of do them as we go this time. So my lead coefficient and my degree. My degree is the biggest exponent. Dang, I wish we'd have had a lead coefficient that wasn't 1 or -1, but it happens. Okay. Domain and range. Domain, all right. Infinity to infinity. Now range, we've been used to having to figure out part of this, but let's think about this for a minute. It's y values from bottom to top. Well, check this out. Bottom's going down forever. Oh, don't do this. If there's arrows both directions, doesn't matter which way, infinite. Yeah, love it when that happens. Saves me a bunch of work. Love it, love it, love it. So like every time, Hardy, it's two ways. Every time, one arrow up and down. That's how we're going to do it. And to finish up. Positive infinity. I'm going to move over just for a sec. My apologies. I made my screen a little bit big this time. Okay. So you know the drill. Left. Negative infinity left arrow. There's my left arrow. Which y infinity is it going towards? Negative infinity. Y goes down as x goes left? Yep. Right side, right arrow. Which infinity is it going towards? Running right into the positive one. Y goes up as x goes right? Yep. And that part's good. Oh, do I want to just keep going? Yeah, I'm going to keep going. We're going to see how this goes. I think what I'm going to do is I'm going to I'm just going to go for it. Here we go. All right, factor each completely. You should have your help sheet at this point. Okay? If you're Mr. H's class, it'll be yellow. So's class, not going to be yellow, but that's okay. Okay, these are usable when we get to this particular quiz. Going out on a limb here. First thing always, factor out common terms. The biggest coefficient, the smallest exponent. Biggest number that goes into 3 and 27 is 3. Smallest exponent degree-wise is x squared. That goes on the outside. It does not disappear. And now what we've been doing in my class is, if you're good enough and you can eyeball what you're missing and put it in the parentheses, outstanding, good work. You probably practiced a lot. If you and practice are not friends and you have no idea what to do at this point, here's what you're going to do. You're going to take your first term and you're going to divide it by this, because at this point we should know our exponent rules. And we know 3 divided by 3 is 1. It just cancels. And we know that 3 minus 2, because that's what you do when you're dividing exponents, is x, or x to the first, and that's what I'm going to put first. And then I'm going to do the same thing with the second term. I'm going to jot down the second term. I'm going to divide it by what's out here. Negative 27 divided by 3 is negative 9. The x squareds cancel because 2 minus 2 is 0. And there's no x squared left here, so I'm done. Now, are you going to get away that easy every time? Heck, no, you're not going to get away that easy every time. So I'm going to keep rolling here to 5. And again, if there's a section as we're doing this that you're like, man, I wish I could see some more of this stuff, go back and look at the videos from earlier this week on factoring, or look into your notes and things last week on the graphing stuff. Okay, first thing again, does 4 go into all of these? That's what I always like to check to see if the number in front goes into everything here. I got to get that clear. It does. Okay, so 4 can come out. Not everything has a V. Don't take any V's this time. So we're going to divide each of these by 4. But this time, there's still a squared here. I got to try and factor this. So this is a multiply and add type of problem. The 4 is not going to disappear. And we've talked a lot about when you're factoring. If the multiply number is negative, and it is here, that means we're going to get one of each sign. We're going to get one positive and one negative. As far as the math part goes, multiplies to 32 but adds up to 4, you can use your chart, you can use your calculator, you can use your brain, but we need to come up with some pairs and say, hey, which of those pairs in some way can get me to 4? Well, 1 and 32 ain't getting me there. 2 and 16's not getting me there. 4 and 8 can though, but I want it to be positive. So the 8 needs to be positive. And I'm good to go. Okay. I'm going to do a couple more here, and then I think I might have to have off this video. We'll see. Let's see, what else we got? We get to 6, and we're like, okay, 2, 8, and 10. I think all of them divide by 2, Hardy. You would be correct. Oh, but this time, they all have A's. Remember, when you're doing degree, it's the smallest exponent. So A, or A to the first, if you would rather. And we start dividing. So I'll do this one more time on one of these. 2a to the third divided by 2a to the first. The 2's cancel. 3 minus 1 is 2. Get the first part. 8a squared divided by 2a. 8 divided by 2 is 4. 2 minus 1 is 1. 4a. And finally, negative 10a divided by 2a. Negative 10 divided by 2 is negative 5. You're like, Hardy, really? I just did all that, now you're going to tell me I got to do this again? We got to try. It may not break down, but we always got to try. So, multiply. Add. Multiply numbers negative, one of each sign. So I need two numbers that multiply to 5 and get me to 4. Well, 5, there's not a lot of choices. It's 5 and 1. Which sign does the 5 get? The bigger one. And we're good to go. So as you're doing these, that's the main key here. I've got to keep looking every single problem, every single time. Is there anything in common? And then I do these two things. I get the biggest coefficient out. I get the smallest exponent out. This one, no number goes into all of them. They all have an R. So basically here, we're just going to subtract 1 from each of the R's. And this time we get a little different when we get to the factoring part. Because this time, my multiply number is positive, but it doesn't mean they're both going to be plus. You're like, what do you mean? When this is positive, whatever sign is in the middle is going to be the sign for both, because negative times negative can be positive. And you're like, okay. So now I can use my multiplication chart. I can use my calculator. You can kind of tell what I like using personally. And again, you're like, well, how do you get those if you're saying you're using the calculator? If you're using the calculator, you just start dividing little numbers in. and you keep doing it. I mean, if they get a decimal, you don't type anything down. But if it isn't a decimal, you just type the two values in. But what am I looking for? I'm looking for 14. I can't add or subtract 20 and 2 to get there. 4 and 10 I sure can. And I'm done. Okay, nothing cute to do when they're the same sign. You're like, okay, I'm kind of starting to see where you're heading with this, Hardy. Good, because I'm going to head down to 10 and 11 because 8 and 9 are a whole lot like the last two we just did. And I think you can do them on your own. So I'm going down to 10 and 11, and here we go. So I get down to here, and I go, okay, 64 and 1. Now, at first I might look and go, ooh, is that perfect squares, Hardy? I see perfect squares, but then I notice something. I notice that that's a 3, which means it's a cube. So now, my perfect cubes are right here, and they're in order. This is 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5, 6, and I could keep going and going. But what I'm going to do here is say, okay, so I cube 4 to get 64, and u to get u cubed. And I cube 1 to get 1. Makes sense. Then I'm just going to flip over, and I'm going to say, okay, there's a plus in the middle. I'm doing sum of cubes. So when I go to do my answer, I'm just going to follow this form. This is my A. This is my B. So when this says A plus B, A plus B, A squared means we're going to square the 4 and the u. So 16u squared. Oops, I almost didn't do sum. Minus, I got to follow my signs here, A times B. 4u times 1, which is just 4u. And then plus b squared, plus 1 squared. Do you have to write the little things I did at the bottom? No. But if this gives you any trouble, you should. And then finally, for my wrap up on this video, one more cube. Again, go get my help if I need it. 125 is 5. So 5a. 8. 8 is 2. 2. Notice I didn't take the negative. The signs take care of themselves when I go to make my form here. So again, the form. This time, since it's minus in the middle, it's difference of cubes because it's minus. So, a minus b, so 5a minus 2, a squared, 5a squared. Square both of them, don't just square the a. Plus a times b. 5a times 2 is 10a. So again, let me write down below what I'm doing so you can see what I'm up to. Plus b squared. Plus 2 squared is 4. Okay? That should get you an excellent start on where we're going here. Now, fair forewarning. You may see some things from our first quiz. You may see a composition problem. You may see, adding like terms and stuff like that. So just to give you a nice, fair heads up here on everything to make sure I'm not trying to pull anything shady or unkind. And you know what I just noticed? I just noticed there's more. And for some reason, Hardy had forgotten this. So let's see. I'm going to do one more piece for now, and then I will make the second video later because I'd forgotten there's a second sheet. And you can now chuckle at me if you would like. Okay, more of those. We're not going to do more of those right now. I'm going to do a couple of these, though. Grouping. Then we'll save the last part for video number 2. So here, when we do grouping, we're doing these separately. So what am I doing in each? I'm finding the greatest common factor. I think this is going to be the last one in this video. We'll do the other half tomorrow. Biggest number that divides into 35 and 40. Multiple ways to do this. You can play with your calculator. You can, if I can get these apart, go to your multiplication chart until you find a 35 and a 40 in the same row or column and follow it up, which would be 5. Smallest exponent. Do your side work if you choose, like we were doing earlier. 40 divided by 5 is 8. 3 minus 2 is 1. Excuse me. Here, 35 divided by 5 is 7. 2 minus 2 is 0. There is no x. So here's the key. When we go to do the second one, this better be the set of parentheses that's left, or we're going to be in trouble. We did something wrong. So let's see what we get. Next one, 56 and 49. Oh dear, 56 and 49. Oh, let's see. Where can I find 56 and 49? Oh, there they are. 56 and 49, 7. 7. So negative 56 divided by 7 is negative... Oh, negative 8. That's not good. Negative 8. How can I fix that? Oh, wait. These are both negative. Let's pull out a negative 7 and see what happens. Negative 56 divided by negative 7 is positive 8. Now we're in business. Negative 49 divided by negative 7 is positive 7, and that's what I needed right there. Those got to be the same, because then I go to do my answer, which is my common factors that I pulled out, so 5x squared and 7, and then my identical set of parentheses is going to be the rest of my quantity. Now for today, that's it. I will do one more double grouping problem for the second video, and then I will also be going back over some of the review items from last quiz that will pop up just a little bit here and there. We'll see you then.